Hello bachcho, let's read this question. So the question says, bomb calorimeters are the devices that are used to experimentally determine delta H and delta U for any reaction by measuring the temperature changes in the water bath. Hence, the experimental data can be used for cross-checking the theoretical data. From the following theoretical data, answer the questions that follow. And some formation enthalpies of compounds and then entropies, molar entropies of compounds are given over here. And the calorimeter data is given, water equivalent of calorimeter, specific heat capacity of water, and mass of water in the water bath are also given. So all data are at 300 Kelvin and R is equal to 2 calorie per mole and per mole per Kelvin. So first question is calculate delta U of combustion of CH4 at 300 Kelvin. Second, calculate the rise in temperature of calorimeter if 0.01 moles of CH4 undergoes combustion in the above warm calorimeter at 300 Kelvin. And third question is, if calorimeter is modified so as to convert chemical energy into electrical energy by ensuring that the reaction occurring at constant pressure, then how much electrical work can be obtained by combustion of 0.1 mole of CH4 gas? So let us solve each question one by one. And here the key concept is calorimetry. Alright, so let us solve the first question first. Delta U of combustion for CH4 at 300 Kelvin. So हमारे पास for combustion of CH4 हमारे पास reaction क्या होगी? This is CH4 gas plus 2O2 gas giving CO2 gas plus 2H2O in the liquid state. और जो enthalpy of reaction होगी here, the enthalpy of combustion of CH4 is same as the enthalpy of reaction, that is equal to the enthalpy of formation of CO2 delta FH of CO2 plus the enthalpy of formation of water, that is 2 into delta FH of water minus the enthalpy of formation of CH4 delta FH of CH4 and जो ऑक्सीजन की एंथैल्पी ऑफ फॉर्मेशन है दैट इज जीरो बिकॉज ऑक्सीजन अपने स्टैंडर्ड स्टेट में प्रेजेंट है. सो दिस इज इक्वल टू कार्बन डाइऑक्साइड के लिए हमारे पास वैल्यू है -90 किलो कैलोरी पर मोल प्लस 2 मल्टीप्लाइड बाय वाटर के लिए हमारे पास वैल्यू है -60 माइनस फॉर्मेशन एंथैल्पी ऑफ CH4 दैट इज -15 माइनस -15. So this is equal to delta H for combustion of CH4 is equal to -90 minus 120 plus 15. So the net value is minus 195 kilocalorie per mole. But हमें क्या find out करना है? हमें find out करना है delta U, internal energy of combustion. So we know that delta U of combustion is equal to delta H of combustion minus delta Ng RT. Alright, so यहाँ पर delta Ng क्या है? It is the change in number of moles of gaseous species in the reaction. So reaction में product side में कितने gaseous species हैं? सिर्फ one है, that is carbon dioxide, but reactant side में total 3 है. So 1 CH4 and 2 O2. So delta N is equal to N of products minus N of reactants. So this is equal to 1 minus 3, which is equal to -2. So हम यहाँ पर values put करेंगे. Delta Hc is minus 195 kilocalorie per mole minus delta Ng is -2 multiplied by R is 2 multiplied by temperature 300 केल्विन गिवन है, बट यहाँ पर कैलोरी में वैल्यू आएगी और हमें इसको किलो कैलोरी में कन्वर्ट करना है, सो विल डिवाइड इट बाय 1000. So here this will be cancelled and we will have this value minus 195 plus 1.2. So this is equal to minus 193.8 kilocalorie per mole. So this is the internal energy change for combustion of CH4. Alright, this is the answer. Now let us jump to the second question that asks us to calculate the rise in temperature of calorimeter if 0.01 moles of CH4 undergoes combustion. Now first हमें क्या करना पड़ेगा, हमें कैलकुलेट करना पड़ेगा कितनी हीट रिलीज हो रही है. So CH4 undergoes combustion to form CO2. Alright, so इसमें जो हीट रिलीज हो रही है that is delta CH of CH4 that is equal to minus 195 kilocalorie per mole. Alright, this is the heat of reaction. Now हमारे पास 0.01 moles of CH4 है, so heat released is equal to, let us say this is Q and this is equal to number of moles multiplied by heat of combustion, और इसकी हम मॉड्यूलस लेंगे क्योंकि we are just calculating the heat released. So this is equal to 0.01 multiplied by 195 kilocalorie per mole and this is equal to 1.95 kilocalorie per mole. कैंसिल हो जाएगी बिकॉज हम मोल से ही मल्टीप्लाई कर रहे हैं. नाउ in order to calculate the heat absorbed by calorimeter, we have to calculate the heat capacity of calorimeter plus water bath, because calorimeter और water bath दोनों ही एक सिस्टम है और दोनों की टेम्परेचर इंक्रीज सेम है. So this heat capacity multiplied by delta T. So this is the temperature difference of the calorimeter. Now heat capacity of calorimeter हम कैसे calculate करेंगे? This is by multiplying heat capacity of water multiplied by water equivalent. And water bath की कैसे calculate करेंगे? Amount of water bath in water bath multiplied by heat capacity of water. So heat capacity of water हमारे पास given है, that is 1 calorie per gram per degree Celsius. That is the specific heat capacity of water, and water equivalent of calorimeter is 36. Mass of water in the water bath is 164. So this is specific heat capacity and this is also specific heat capacity. So specific heat capacity is 1 calorie Kelvin inverse mole inverse multiplied by water equivalent is, so this is gram inverse not mole inverse, Kelvin inverse gram inverse multiplied by water equivalent is 36 again plus amount of water in water bath, that is 164 grams multiplied by specific heat capacity of water is 36. This is 1 calorie gram inverse Kelvin inverse. So the net value is 36 calorie Kelvin inverse plus 164 calorie Kelvin inverse, and this is equal to 200 calorie Kelvin inverse, and this is the heat capacity of calorimeter, और इसके साथ हमें मल्टीप्लाई करना है डेल्टा टी को. So heat absorbed is equal to heat released. All right, this is the fundamental formula of calorimetry. So heat absorbed is 1.95 kilocalorie. So 1.95 kilocalorie is equal to, so this is the heat released, or we can put it on the other side. Heat absorbed is 200, the specific heat capacity or the heat capacity of calorimeter multiplied by delta T. So this is 200 calorie Kelvin inverse multiplied by delta T, which is equal to heat released, that is 1.95 kilocalorie. 1.95 kilocalorie का हम simple calories में भी express कर सकते हैं, that is by multiplying it by 1000. So 1950 calorie. All right. So इसमें से हम delta T को calculate कर सकते हैं. Delta T is equal to 1950 calorie divided by 200 calorie Kelvin inverse, and this value is 9.75 Kelvin. So the temperature difference is delta T is equal to 9.75 Kelvin. This is the temperature difference of calorimeter and water bath system. Now let us look at the third question. If calorimeter is modified so as to convert chemical energy into electrical energy, then at constant pressure, how much electrical work can be obtained by combustion of 0.1 mole of methane? Now, let us calculate the delta G. And as we know, delta G is equal to delta H minus T delta S. So इसके लिए हमें delta H की वैल्यू चाहिए जो कि given है, और we calculated it, that is minus 195 kilocalorie per mole, and we have to calculate this value delta S from the given data. So given data में क्या है? Entropy of methane, oxygen, water and carbon dioxide are given. So delta S will be summation of entropy of products minus summation of entropy of reactants. So this is equal to, जो हमारे पास reaction है, that is CH4 plus 2O2 gives CO2 plus 2H2O. So 2H2O, that is 2 multiplied by entropy of H2O plus entropy of CO2 minus entropy of CH4. So this is S of CH4 minus 2 multiplied by S of O2, और यहाँ पर हम वैल्यूज पुट कर सकते हैं. सो H2O की है 15 एंड CO2 की है 50. सो 2 multiplied by 15 plus 50 minus S for CH4 is 40 minus 2 multiplied by S for O2 is 45. So this is equal to 2 into 15 plus 40 is 2 into 15 plus 50 is equal to 80 minus 40 minus 90 is 130. So this is equal to minus 50 calorie Kelvin inverse mole inverse. All right. Now we have to calculate the delta G. So delta G is equal to delta H, that is minus 195 kilocalorie Kelvin kilocalorie per mole minus T delta S. So T की वैल्यू गिवन है 300 केल्विन, 300 मल्टीप्लाइड बाय डेल्टा एस इज -50, हमने अभी कैलकुलेट किया, -50 कैलोरी केल्विन इनवर्स मोल इनवर्स. ऑलराइट, सो दिस इज इक्वल टू, हम अगर किलो कैलोरी को कैलोरीज में कन्वर्ट कर दें देन वी हैव टू मल्टीप्लाई इट बाय 1000. सो 195000 calorie per mole minus 300 multiplied by -50. So this is equal to plus 300 into 50 calorie per mole. So इसकी जो वैल्यू है, this value is equal to minus 1,80,000 calorie per mole, or this is equal to minus 180 kilocalorie per mole, and this is per mole, but यहाँ पर given है for 0.1 mole of CH4. Then for 0.1 mole of CH4, the work or free energy, or we can say free energy change, or delta G, will be number of moles multiplied by delta G naught. So N multiplied by delta G naught, that is 0.1 multiplied by minus 180 kilocalorie per mole. So this will be equal to minus 18 kilocalorie per mole. Now ये free energy change है, and free energy change is the maximum amount of work that can be obtained from a reaction. So amount of electrical work is equal to 18 kilocalorie, और यहाँ पर per mole और नहीं रहेगी क्योंकि हम number of mole से multiply कर चुके हैं. So the amount of electrical work would be 18 kilocalorie, and this negative sign is ignored because we are just talking about the amount of work. This is the required answer, and I hope you understood the concept well. Best of luck.